Okay, folks, section 11.6, the Pythagorean theorem. You know, what can I say about the Pythagorean theorem? It's probably the best known mathematical idea in the world. We call it the Pythagorean theorem, and it's named after Pythagoras, an ancient Greek. But the Chinese knew this idea long before the Greeks did, I believe. That's been recently proven. Also, the Egyptians used an idea close to this. But here's what Pythagoras says, okay, or the Pythagorean theorem says. If you have a right triangle, and it has to be a right triangle, okay, this side, the side opposite the right angle, is called the hypotenuse. Hypotenuse, okay? The two sides that make up the right angle are called the legs, okay? Not plural. Okay. Hypotenuse. Sorry, guys. Here we go. I'm going to get it straight. Just hang in there with me, guys. All right. Those are the parts of the right triangle. Okay. Now, in the Pythagorean theorem, what it says is we're going to name the legs A and B. It doesn't matter which one you call which, but C is always the hypotenuse. Okay. So be sure that you keep that straight. C is always the hypotenuse. And what the Pythagorean theorem says is that if you take the length of A and square it, you take the length of B and square it, add those two things together, you're going to get the length of C squared. Now remember, this is always the hypotenuse. Okay? A and B are the legs, and it doesn't matter which one's which, but the one that's by itself on the other side of the equal sign is always the hypotenuse. So let's take that idea. Let's go down here to example number 1. And it says, refer to the triangle at the right, okay, ABC, good. Find the missing length correct to the nearest hundredth, which means I'm going to use a calculator, okay, since I'm rounding. I don't know what A is, so I'm going to say A squared plus 11 squared is equal to 17 squared, okay? Well, let's start simplifying. That's A squared plus 121 is equal to 289, okay? Now I'm going to subtract 121 from both sides, and I'm going to get that A squared is equal to, let's see, 8, excuse me guys, I need to say, excuse me, 8 minus 2 is 6, 2 minus 1 is 1, 168. It's going to be a little less than 13, let's see. We're going to take the square root of both sides, and we're going to get that A approximates, all right, the square root of 168 is equal to, or approximately 12.9614814. They said round to the nearest hundred. That's 2 places. Okay, so that means A is approximately 12.96. Because when I look at the 1, it's not big enough to make the decimal point go up. All right, so A is approximately 12.96. Approximately 12.96. Let's see, B was 11, C is 17. Something you should know is that the hypotenuse is always the longest side, okay? C is always bigger than A or B, okay? Not A and B. It can't be bigger than A and B. A plus B is always bigger than C, but C by itself is always bigger than either of the two legs. It's the longest side, all right? Let's look at the next one. Now, the thing is, that if you have a right triangle, you know that A squared plus B squared equals C squared. But also the converse is true. If A squared plus B squared does equal C squared, then it is a right triangle. All right? So look, here's the longest side, so we're going to call that C. All right? And this is A and B. So let's see if this is true. 16 squared plus 32 squared. Does it equal 36 squared? Okay? Well, let's see. 16 squared is 256. Ooh, 32 squared is 1,024, I think. Let's see. Yes, it is. Ooh, Mr. C. Awesome. 36 squared, I have no idea. Let's see. 1,296. Oh, 1,296. Come on, Mr. C. Get it together. 1,296. Question mark. Is that true? Well, let's see. 256, 1,024. And 256. Oh, no. 1,280. does not equal 1296. Not a right abbreviation, triangle abbreviation. Okay? All right, simple enough. If they don't give us, if we don't know if it's a right triangle, we can use the Pythagorean theorem to see if it is. Okay? All right, let's look at the next one. Keep rolling here. Find the missing link correct to the nearest hundredth. All right, well, I know my formula says that a squared, or the theorem, a squared plus b squared is equal to c squared. Let's fill in what I know. I know that a is equal to a half b. So that means 1/2 b squared plus b is 14. All right, so 14 squared is equal to c squared. Okay. Okay. Let's see. Wait, half of b? Half of b is 7. I was worried there for a minute, guys. This is b, it's 14. A is half b, so that means that a is 7. So I can write this as 7 squared plus 14 squared is equal to c squared. Man, it took me a minute to figure out what was going on there. All right, so 49 plus 14 squared is 196 is equal to c squared. All right, they said to the nearest hundredth, so I'm going to round here. Let's see, 50 would, I don't know, what is that, 45? 245 is equal to c squared. It's going to be a little less than 16. Let's take the square root of both sides, all right? And c is going to be approximately, and Mr. C, why don't you use the negative? Because whenever I take the square root of a variable, I need the positive and the negative. Yeah, but this is a triangle. You can't have a negative length of the hypotenuse, okay? All right, so we're going to get 15.65247584. Round that to the nearest hundredth. Look at my 2. 2 is too small. So C is approximately 15.65. And that's my answer. Nice. Okay? So I know that A equals 7, B is equal to 14, and C is approximately 15.65. Okay? All right, we're rolling. Let's keep it going. Look at the next one here. Oh, of course. Of course they're going to give us a word problem because that makes sense. We need to be able to solve problems. That's what we do. Make a sketch for each problem. All right, I will. Approximate each square root to the nearest hundredth. So I'm using my calculator. A calculator may be helpful. All right. The dimensions of a rectangular doorway are 200 centimeters. Okay, 200 centimeters by 90 centimeters. Okay. Can a tabletop with a diameter, okay, well that must be a circular table, of 210 centimeters, the diameter is 210, be carried through the doorway? So if I tip it up on its side and I try to roll it through, right, I need to see, that's my table, right? If I take the legs off, right, here's the table, and I'm trying to roll it through the doorway. The question is that hypotenuse of that triangle right here, is it more than 210? Because if it is, then I can fit the table through it, but if it's not, I can't. Well, I know that a squared plus b squared is equal to c squared. That means that 200 squared plus 90 squared is equal to c squared. This is c, right? 200 squared, I don't know, that's 4 with 4 zeros. 40,000 plus 81 with 2 zeros, okay, is equal to c squared, all right? When I add those together, that's going to be 48,100. Rolling without my calculator so far. But now, I'm going to take the square root of both sides. It's a table and a door, so I can't have a negative length. All right, but c is going to be approximately, let's see, square root 41,800. 204.5. I rounded to the nearest 10. Okay? It doesn't say what we're to round here. We're just supposed to answer. Can it fit through the doorway? And the answer is no. Because the longest length through the doorway, of course, is going to be the hypotenuse of this right triangle, right? And it's shorter than the diameter of the table. So no, the table can't fit through the doorway. All right? Nice. Okay, I think they've got one more for us here. Let's check it out. Here we go. Find the area of a triangle And the area of the triangle, okay. Well, wait, the area of the triangle is equal to 1/2 times base times height, okay? Find the area of a triangle with 3 sides of length 4. So all 3 sides have a length of 4. I want to make this a little bit bigger. Okay, just so I can work with it here. Okay, so this is 4, and this is 4. Hint, find the height first. Okay, well, if I drop a line straight down, okay, straight down, this is 2, right? Right? Because it cuts that bottom part in half, and this is 2. So I wonder what this is. Well, think about this. I'm just going to draw a little triangle over here to the side, right? Here's half of the triangle. Here's 4, right, which is this part, and 2. And here's a right angle, right? Because the height always forms a right angle, or it's not the height, okay? We don't want something slanted and say the height's over here. That doesn't tell me. When you measure someone's height, or the height of a room, you don't measure from one corner to the opposite corner. You measure straight up and down, okay? All right, so this is a right angle. This is a leg and this is a leg, so this, I'll call that B, okay? All right. All right. Now, that means that 2 squared plus B squared is equal to 4 squared. 4 plus B squared is equal to 16. Did they say round this? Yeah, to the 100, okay? Minus 4 on both sides, B squared is equal to 12, take the square root. Now the only thing I'm going to round is my answer. So B is approximately, I'm going to be working with a long number here, not a big one, but a long one. All right, square root 12 is equal to 3.4641011615. Okay, that's what B is. Now remember, area is equal to 1/2 times the base, which is 4, times the height, which is 3.4641011615. All right, so I'm going to multiply. Look, half times 4, that's just 2, right? 2 times that stuff again, 3.4641011615. Okay, so times 2. So the area equals 6.928. And I can stop there because they wanted to round it to the hundredths. And that is big enough to make this go up 1. So area is equal to 6.93. What? What units were these? Centimeters. And since it's area, it's squared. All right. All right. Man, Pythagoras. You know, the Egyptians used it a lot because the Nile River would flood every year, and they would have these posts that they would set out. And they would use different mathematical formulas and stuff to make sure that people kept the same property lines that they had before the Nile River flooded, because it would change each year. You know, when you start flooding and it carries sediment, the land or the amount of exposed land changes, you know, from year to year. So that's what would have motivated them to use this. So, okay, let me see. Do I have something else? Oh, man. All right. You guys are ready. See you later.